Hi, my name is Ashish Diwan. I work as a consultant at ECN. In this video, I'm going to give you a demonstration of the ECN Install software, which is a time simulation tool for modeling installation planning for an offshore wind farm. After the tool is installed, an icon like this would appear on the desktop. If you are having a full version of the software, then it will be like this, but if it's a trial version, then you will have trial written at the end of the icon. If you double click the icon, the splash screen will appear with the ECN Wind theme image. Loading the project might require a couple of minutes based on the RAM of your computer and the number of the programs currently opened. When the tool has just started for the first time, there will be no project defined yet. So we have to specify a new project to model an installation scenario for an offshore wind farm. One option is to start and specify a completely new project and an empty project. However, to better understand the functionalities and the use of the software, it would be better that we opt for a default project. This project is inserted in the software, giving the user to understand the complete capabilities of the software. Further, I will give the name of the project as demonstration. The creation of the project can take around 15 to 20 seconds. Note that once a project is created, all the tabs input data, planning, processing, and results are loaded. The input data contains the common parameters defined for the entire installation planning. Let's wait till the project is created. Now here you can see that there are 9 input parameters that needs to be defined by the user. Let's start with wind turbines. The user specifies the type of the turbine that is going to be installed in the wind farm. The characteristics of the wind turbine like name, rated power, rotor diameter, hub height, and total number of turbines to be installed in the wind farm are entered. Last, the power curve for the wind turbine is imported. Once the power curve is imported, it will be plotted in the figure below. Now let me show you the format in which the power curve Excel file is required. It's simple. 2 columns, wind speed and power, specified for the wind speed of 1 meters per second till 25 meters per second. The power curve is required for estimating the losses due to the delays in the installation time and the amount of the power and the revenue the wind turbines could have generated over the lost installation time. It should be noted that in an installation project, the user can install multiple wind turbines. So just add a new wind turbine and specify the properties as mentioned before for the other turbine. Let's say that we go for test, rated power 4, rotor diameter 100, hub height 100, number of turbines 10. And to import the power curve, I have one saved here as a sample, and I just select that. The program validates whether the power curve is in the right format or not. And here you can see that we can just add the new test turbine in the program. Please note that once you want to edit something in an existing wind turbine, you just have to change the value and then click edit, and the values are automatically saved. However, for saving it for the entire project, make sure that you click on the save project after every 10 minutes so that you don't lose any data over the period of time. To show you the option of the delete, so we have the test turbine selected, you just click delete and you can see that the same turbine that you added has been deleted. If we click on the save project again to go back to the default settings. Now let's go to the next section, which is climate data. Here the user imports all the different climate data files corresponding to different locations. For example, here as default project only one climate file is inserted. However, the user has an option to choose for multiple climate file representative of different locations like a harbor climate data file, offshore climate data file, etc. There are three important things to note here. 1. The resolution of the climate data needs to be either 1 hour or 3 hours. Second, the format of the climate data is quite specific. You can see here there are 7 columns that needs to be imported. The first row is a free format and the rest of the rows are inserted as per this format. Again, note the 3-hour resolution which can be seen here. Last thing to note in this section is that you require a minimum of 1 year of weather data or climate file Excel sheet, and it should start from 1st of January and end on 31st of December. Next comes the operation basis. You can see here that as part of the default project, some 4 to 5 ports have been added. For each of the operation base, the average distance to the cost per day of the harbor, and the harbor delay needs to be specified. The climate data files which were added in the previous input tab are selected from a drop down in order to attach the relevant weather data to this base. Also, besides the onshore bases, there can be one or more offshore bases. By default, there is a base named wind farm. Here you can see that. For the same, only climate data file is selected. The other parameters are disabled. Moving on, the components to be installed need to be inserted. The list includes all the components which are part of the installation plan. For every material or component, the cost per unit and the weight of the component is required to be entered. Normally, the costs are entered in euros per ton, but in this software, they need to be input as euros per megawatt, or let's say euros per kilowatt. Further, the two most important inputs, equipment and vessels. The user is obliged to create a library of input equipment which will be used during the actual implementations or installation. Usually, equipment will be stationed on one of the main installation vessels or to be deployed by itself. It's not necessary that the specified equipment is part of the actual installation modeling. In short, corresponding to each equipment name, cost parameters are entered. Then different operation and weather restrictions are specified for each equipment. For operations, the operation name and the duration is specified, whereas for weather restriction, a restriction name and corresponding limitations of wind speed, wave height and currents is entered. Two things to note here. First, although the unit for the operation duration is hour, the internal resolution used in the entire modeling is as small as 6 minutes. For example, if the user specifies 2.1 hours, it is considered as 2 hours and 6 minutes. Second, the operation name and the weather restrictions name don't have to be the same. You can see here that we have two operations, burying and burying infill, but the weather restriction is only there for the burying, so which means that the same weather limits could be used for both the operations. Now, moving on. Now, as was done for the equipment, the library of the vessels is created by the user. This is the list of some of the vessels used in the default project. A similar approach of entering the cost parameters, the operation specifications and weather restrictions are followed here. In addition, the transport capacity and the travel speed of the vessel and the maximum technicians on board are also mentioned. Finally, the last three inputs, the working shifts. One of the most important aspects of the project is the technicians without whom the installation cannot be completed. Their working pattern is selected in this list. The working shifts are divided in 4 seasons, and for each season there are 2 types of shift patterns which can be followed. Either regular shift, or let's say a single shift, or 24-hour 7 shift, or in other words multiple shifts. For this version of the tool, the freedom to choose different options in the shift patterns is limited, but should be sufficient to reflect the real offshore wind farm installation scenario. Costs. Then besides the cost parameters that we have already specified in operation basis, components, vessels, equipments and working shifts, there are miscellaneous costs surrounding the actual installation process. Some of the example costs are project management, consultancy, development, etc. These can be entered here, and in addition there is an input called electricity price which is required for estimating the revenue losses and also needs to be entered here. Last details as part of the input data to be entered is permits constraints. For any offshore installation, there can be different constraints which are valid for a certain period. For example, in Netherlands, the piling process is not permitted between the 1st January and the 1st of July. Such permits and constraints can be inserted here. Please make sure that on regular time intervals, click on the Save project so that you don't lose any data which is being entered by you. After the input data module is completed, the next module is the planning steps. This is where the actual installation process is defined. I will first show you what has been added as part of the default project, and then later I will add another sequence and show you how to create and add your own planning sequences. First, let's observe what we can see here. We can see that there are 2 sequences defined. One sequence is that of the installation of the foundation, the other sequence is that of the installation of export cables. Corresponding to each of the sequence, there are sequence details which are mentioned on the right pane. So first there is an automatic sequence ID, a name which the user has entered, and the number of the iterations. So this means that how many times that you want the entire installation sequence to be repeated. For each sequence, there is a start date which is specified. A unique sequence color can be chosen based on user liking. Parameters like the number of the groups, the number of the unique steps in the sequence, and total number of steps in a sequence are calculated automatically by the program. Suppose you can load 3 monopiles on the vessel and need to install 50 monopiles. This means 16 identical sequences and 1 sequence only involving the last 2 monopiles. Now if I open a particular sequence, the next level of the detail is called group. So for easier understanding, you can say that a sequence consists of a number of groups. Similarly, when you click on a particular group, on the right hand side you can see the details of the group. Again, the most important being the name of the group and the number of the iterations of the same. Here also the untouchable parameters are calculated automatically by the program. The last level of detail is called a step. Overall, the entire installation process is broken down into small steps. Here you can see that I have a loading step, I have a traveling step, and probably I will have one installation step. A collection of steps is formulated in a group. Here you can see that all these collection of steps is one group and it is repeated this many number of times. Again, a step can also be repeated, as I said, as was the case for the groups and the sequence. On the right hand side, you can see that there is information of each of the step characteristics. To start with, a step ID. So we'll go, let's say, for a loading step. So a step ID is automatically inserted by the software. Here you can see 1.1.1 states sequence 1, group 1, step 1. Then a step type is selected. Note that if the operation to be performed is loading, mobilization or demobilization, then the step type has to be selected as organization. Further, if the step involves an operation traveling an actual installation offshore, then the step type selected is installation. Let me give you an example here. This is what I meant. Moving on. The location start and the location end are selected from the list of the operation bases the user has defined. Note that the location start and the location end are different if there is a traveling step involved. Let's say, for example, in this case. Next set of inputs is defining the vessel to be used for that step. So a particular vessel is chosen from the library. Here you have all the lists that you have defined in the library. Then from the list of the operations that were defined for that vessel, here you can see all the list of the operations that were selected or that were created for that vessels are shown here, and you select one of the vessel operation. The duration is automatically loaded. If it is a loading step, the components which are required to be loaded are defined, and if it's a mobilization step, the cost percentage is fed in. Let's say for a loading step, here you can see that the components have to be specified as to how many components are you going to load for that particular operation. Let's say in this case it's foundation, so we can see here, we can go to monopiles and you can see one monopile is being loaded. And if it is a mobilization step, which for example in this case maybe it's here, yes, so if it's a mobilization step, this is what I meant by the cost of the mobilization demobilization that has to be entered. I'll go back to the same first step of loading monopiles. Another thing to note actually is the if it's a sailing step, the vessel operation and the vessel restrictions are always termed as sailing, which the user is expected to select when defining a traveling step. Just to give you to repeat what I just said and demonstrate you. So here you can see that sailing is something by default that was created and is selected by the user in the step details. Going back, the next parameter to be selected is the equipment. So if there is no equipment required, then no equipment is actually selected. After all, the corresponding inputs are disabled. However, if a particular step is using equipment, let's say like in this case of piling, the equipment is selected from the drop down, which is a list defined in the input data. There you can see you have selected the hydro hammer for the installation in this case. The equivalent operation and the durations are selected. The next set of the inputs for the step are required to explain the suitable working shift, step duration and constraints. Although the step duration is automatically computed based on vessel and equipment operation, the user can overwrite what was defined or computed. Let's say 4.5 is something that is computed automatically based on the equipment operation time or the vessel operation time, but you always have a choice to overwrite it. I will leave it back as it is. Then the weather duration as an input, which certain users would prefer to have a larger window for a particular operation so as to safeguard any delay in critical operations. By default, the step duration and the weather durations are same. You can always increase this if you want. Step splittable is an option which allows the user to choose whether it wants to perform the step in one single shift or by breaking into multiple shifts. For example, in this version of ECN Install, traveling step by default is a non-splittable step. Let's say you can see here, I can go back to the traveling step. It's always going to be a non-splittable step. That's why it's disabled. Then from what the user has defined for the working shift, the user can also choose a suitable working pattern. For the default project, all the steps are performed under multiple shift, that is 24/7. The associate number of technicians required for the step are also entered and defined. In this case, I think I have entered 20 for all the steps for the default project. Next, most importantly, the weather restrictions are defined. By default, as a starting point, the program automatically calculates the minimum of vessel and equipment weather restrictions defined by the user. The user has full authority to override those limits for a certain step in this spot if he feels that those steps not really represent the automatically calculated numbers. One useful feature of this tool is the option of choosing the weather restriction based on hub height. Let's say, for example, in this case. By default, the weather time series that are available are measured and compiled at mean sea level. However, for blade and nacelle installation, the same weather restrictions cannot be used. Hence, the user can choose if for a certain step it would prefer to consider hub height weather restrictions or not. Here you can see that you always have an option to go for either the mean sea level or at the hub height for the actual installation process. From the values further moving on, we have the last set of the inputs required, which are the iteration settings. How many times do you want to iterate this step? At what location of the group or the sequence do you want to iterate? And finally, what is the learning curve for this iterative process? For example, over the time you feel that your process can be improved and can be made quick as based on your experience, a certain learning curve rate can be defined. You can press this button and calculate your learning curve automatically and enter that value over here. 100% actually means that there is no learning curve and all the values for the same step are remaining same. So till now you have seen that how we went through all the entire planning module. As I mentioned before, this is the explanation of what is present in the current default project. However, if you want to add and modify another sequence, this is how the user can do it. The user can click on the plus sequence button. So here you see that by default there are things which appear. The user can modify the sequence entered or keep it like what it appears. I will leave it as sequence 3. Also, you can observe that by default there is a structure of a sequence, a group and a step. The user can also create multiple groups or multiple steps. If I just click on this and want to have copy and paste it, so let's say if I click on a sequence and I just copy and I paste it here, you can see that the entire sequence has been pasted and that same group is also pasted. If you want to move the step up and down, that is also possible with these buttons. As explained before, the step details are required for each step by the user. Here I will delete the sequence that we created for the demonstration process. And now we have exactly the same input as we had for the default project. And I just save the project again to make sure that no things are saved unnecessarily. Up till now, we have defined all the inputs for the installation modeling. The next module, that of the pre-processing, is a section to give an impression of the input data and the planning. So here we go for the pre-processing. There are 3 main pre-processor segments. The first is the weather, the second one is the time, and the last one is the cost. Additionally, all is a segment which pre-processes all of them. Let's go through them one by one. The weather segment provides the user an initial impression of its weather data. One can get the weather overview per month and per year. Also, the workability in terms of accessibility and windows per month can be calculated. Here I will select 2 years of weather data out of the 20 years of the weather data that we have imported as part of the default project. To explain the significance of this selection, selecting 2 bad weather years will influence workability downwards. Selecting 2 light weather years will influence the workability upwards. Selecting years in a long yearly database will give you a P50 weather scenario. Select a suitable operation that we have mentioned in the step definition. So for example, that I go for an operation which is more sensitive. In this case, let's go for a piling operation. We shall select for the duration, we should select something like 12 hours. So that means that we would like to have or find 12-hour weather windows. So let's process the weather data and see what we can have as an overview of initial estimates. So here you can see you can have weather data per year, you can have weather data per month. You could also have a workability which gives you a percentage accessibility and try to understand in what months could be the best for doing a particular operation. The last one is actually the number of the workable windows available for doing such an operation. The next segment is the time. Based on the installation planning provided by the user, it just summarizes the time durations and the sequences. The total project duration is also calculated. The user also has an option of exploring the planning in the form of the Gantt chart. Make sure that MS Project is installed in order to make the functionality work. The last segment is the cost. The user can get an initial estimate of the breakdown of its cost. So if I press on this pre-process, there is an initial pre-processing of the cost, and here you can see that the major costs are vessels, components, and fixed costs. Then after the pre-processing and getting an initial impression of the weather data, time, and cost, the user is obliged to perform actual simulations. You could either use the same years that you selected in the preprocessor or completely start afresh by selecting years manually. In the default project, all the years are chosen, and I will let the settings be like that. Also, you can choose which outputs you would like to have. The outputs are expressed in the form of an Excel sheet, MS Project, and the graphs. I would leave it unchecked by now and select the outputs later in the results module. Next, Simulate button can be pressed to run any installation scenario. Note that if you have the trial version of the software, the results are already simulated for the default project. Hence, I will leave it for that to detail more. Although I have, because I'm working with the full version of the tool, I will simulate the installation process. The simulation time can take approximately 45 seconds. Wait till the processing screen disappears. Because it's simulating around 20 years, it can definitely take some time, and you can imagine that if the number of the years that are to be simulated are less, it will take less time. Next, as I mentioned before, the outputs are displayed in the form of the Excel sheet. Here you can see in the export module in the form of the Excel sheet, the Gantt chart, and the graphs here. For the trial version, only for the default project these features are available. However, here I will write the output results to the Excel sheet as I did for the simulation process. The user can click on the open directory where the Excel sheet is placed. This process again of writing the data to the Excel sheet can take a bit of time, as there is a lot of information that has to be reported for 20 years of weather data. So here you see it automatically opens, and here you have the Excel sheet. So let's see what the Excel sheet has in it, and what are the summary, or what is the final summary that it provides. The first tab gives a nice overview of the results, and I will just move this mouse here. The project duration, the delays, and the cost associated to it. Here you can see all of that. The delays breakdown is iterated well in this sheet. The user also gets an impression of each of the simulations in terms of the years performed. The list here gives the entire list of the planning output with the starting time and the ending time of each of the step. At the end of the Excel sheet, and here you can see, if you just click on this, there are 4 tabs with respect to the input, and they are divided, and the input information is divided over general input, resource input, and wind turbine input. Everything is combined and summarized in this Excel sheet. The same procedure as followed for the Excel sheet can be followed for the MS project, or for creating the Gantt chart. Make sure that you have the MS project installed to avail the functionality of the program. Last form of the output is the graphs. Overall, there are 22 graphs possible to be generated from the ECN Install software. For the trial version, all the graphs are available for the default project. However, for the new project, only 3 graphs are activated. Let's say I select only 3 graphs here. Once you select the graphs you want to generate, click on the button Produce to produce the graphs. It will ask you if you want to overwrite the existing graphs. And the program can take some time because we just generated 3 graphs. It was quite quick. The graphs are saved in the same directory mentioned here. You can always choose another file path to save your results. The ECN Install has a nice feature of viewing the graphs also in the software. Click on the Load Graphs to load all the time, cost, and resources graphs. The graphs are saved in the project folder, which can also be accessed by pressing Open Directory. So here first I'll show you how you can view it in the software itself, and then I'll show you that all your graphs are actually saved here as part of the project folder. Make sure that once you have generated the results, always press on the Save button here to make sure that all your inputs and the outputs are saved properly. So here the project data has been saved, and you have created a one complete project of ECN Install. So that was a brief insight into the ECN Install tool, and hereby I would like to conclude the demonstration of the software. My name is Ashish Diwan, and if you have any questions you can reach me at diwan@ecn.nl or call me on +31 2245 68109. Thank you for your attention.